Introduce this morning's keynote speaker, Dr. Radley Horton. Dr. Horton is a Lamont Research Professor at Columbia University's Lamont-Doherty Earth Observatory. He is on the vanguard of climate researchers today and is among the short list of contemporary scholars often asked to speak to the current issues of climate extremes and their impacts on communities nationally and internationally. Dr. Horton's research and scholarly work crosses the range of studies from climate to sustainability. He was the convening lead author for the third National Climate Assessment. These National Climate Assessment reports are multidisciplinary efforts to synthesize the science, explore the consequences of climate change, and beginning with the second report, identify mitigation scenarios. These reports are meant to inform policymakers in the US. The third assessment, published in 2014, was written by more than 300 authors drawn from academia, local, tribal, and federal governments, as well as the private and nonprofit sectors. You can see these are massive undertakings and the magnitude of the honor. Audience, feel free to put questions into the Q&A during the talk, but we will hold questions until the end of the presentation. It is now with gratitude and pleasure that I introduce Dr. Radley Horton.
Good morning, everyone. Thrilled to have the chance to be here with you today. Give me 1 second to start my screen share, because I'm not great at multitasking here. Okay, I'm hoping right now everyone can see a blue slide. Is that right? Everybody see that okay? Okay, wonderful. Yeah, so it's really an honor to be here with you all today. As we just heard, I'm a climate scientist, spend most of my time thinking about how extreme weather events may change in the future with increasing amounts of greenhouse gases in the atmosphere. Also about how society is impacted by those changes in climate and what we can do to better prepare by reducing emissions and adapting to those higher temperatures, higher sea levels, and more flooding that we're going to see in the future. I have to say up front that I have so much to learn on issues of environmental and racial justice. So I really am humbled and honored to have the chance to learn more today. But I'm going to try to provide that climate science foundation, and for the slides that I run through, to give us some entry points to think about the manifold, multiple ways that racial justice issues are directly connected to climate issues. We can't solve the climate problem without thinking deeply about equity and historical injustices. So just to establish a little of that framing up front, before I go into our climate science overview from a global perspective, and then honing into the New York City case study to learn how our climate is changing here in the city already, how we're being impacted, and how the steps that the city and the state are taking to reduce emissions and be more resilient. So a few takeaways though up front, and these will be obvious to most of you, but just to really highlight them. Some communities are far more exposed to climate hazards than others. We don't see the same temperatures when a heat wave happens. Some parts of the city can be almost 10 degrees Fahrenheit warmer than other parts. Some areas are much more prone to coastal flooding. But then getting to that second point in green, even for a given amount of temperature or a given amount of sea level rise, there's going to be differences in vulnerability. The effects are going to be worse for some communities than others. So here we need to think about issues related to, for example, are there pre-existing health conditions? Have people been exposed to a lifetime of stress because of legacies of racism, for example? Are some communities more exposed to air pollution along with those heat waves? These are the kind of things that mean even if different communities experienced exactly the same temperatures and rainfall, why some communities would be hit much harder than others. And then similarly, there are issues related to adaptive capacity. Who has access to these financial networks, for example? Who can get funding? Who has other options if there are situations where you need to move away? And then also, in the realm of the very obvious, not all communities, not all countries have contributed the same amount to this global warming problem. Far from it. Some countries, including the US, much of Western Europe, today are still responsible for far more emissions per person than most other countries. But we can't even just think about the emissions today, because as we're going to see, greenhouse gases last in the atmosphere for a really long time. One consequence of that is that it means that it matters a lot who was emitting the most 30, 50 years ago. And there it's even more true that it was the Western nations that contributed far more to this problem today of sea level rise and higher temperatures. And frankly, profited immensely from not having to pay the social costs, the environmental costs of that pollution, especially for vulnerable communities. So that's a frame that we can be thinking about as we go through this largely climate science presentation, but we will go deeper into these issues in the last parts of my talk. Okay, so a quick zoom in for New York City, just to highlight some of these points, that vulnerability is so far from being evenly distributed. If we look at some of the communities shown in red, where there's going to be extremely high vulnerability to climate change, these are the neighborhoods where we've seen legacies of racial injustice, where we see deep-seated issues of poverty and unfairness. So that maps directly onto where we see the greatest climate vulnerabilities. As we're thinking about issues of equity during this presentation, it could be helpful to think about three frames that have been applied by co-authors with the New York City panel of climate change. Robin Lashenko, who we're going to hear from in a little bit, central to developing this kind of framing. So we need to be thinking about distributive equity. That's largely what I've been talking about so far. Who's more vulnerable? But we also need to be thinking about this issue of contextual equity, which really is getting at the question of why. Why is it this way? It's combinations of political processes, economics, social, these systemic structural racism issues that help shape that uneven vulnerability. If we don't tackle these issues head on, we're not going to be able to make a better future for all. And then also this procedural equity point is so critically important, getting at issues of inclusion. As a climate scientist, I can say that we do not have anywhere near enough diversity and representation in climate science. And because of that, we're missing critical voices. We're not doing the best science that we could do. And when we're trying to be impactful in our work to help vulnerabilities in certain communities, if we're not engaging deeply, if we're taking a traditional top-down model of just pretending that we're the experts, we're not going to be coming up with the most impactful solutions. We're not going to have the chance to learn because we're missing that expertise that's on the ground in communities. So we really need to develop this two-way framing that acknowledges expertise across all of society and is built on inclusion. Okay, so with that introduction out of the way, let's get into the heart of the talk now. So I'll begin with this global climate science overview. It includes the scientific foundations. How do we know that we're warming the planet? What are the effects going to be? We'll hone in on extreme events as particularly impactful for societies. We'll talk about what some of those impacts are going to be. Then we'll pivot to this sort of looking forward view. What are some of the really emerging trends and topics in climate science that it's important to be abreast of? And what's happening in the way of global policy solutions to reduce emissions, to be better prepared and more resilient. Then we'll really hone in on the New York examples. I'll talk about the process that New York City is using to address these risks. We'll step back and look a little bit at New York State's efforts, very ambitious around greenhouse gas mitigation, and elements that they have that include really thinking about just transition as well. Okay, so jumping right in here, I'm hoping that folks are now seeing an animation. This is just showing us, going back to late in the 19th century, how quickly the planet has warmed. So we're moving through time in 5-year periods. You can see now we're at about the 1960s or so. watch how yellow, orange, and red colors are starting to take over as we get to the 1990s, the 2000s, 2010s. Those yellows and reds are showing 5-year periods that are much warmer than the long-term average temperatures were from 1950 to 1980. So we'll run that one more time. You can see in the early period, late in the 19th century, a lot of blue colors. But as we move decade by decade, the statistics really start to shift around 1970 or so. It becomes difficult to have a cooler than average 5-year period. And as we get towards the end of the period, a lot of these high latitude regions are really screaming with red colors. The statistics have shifted. This is not the same planet that a lot of our infrastructure, our agricultural systems were developed for. So we need to prepare. It's not just temperatures that are going up though. We're also seeing the oceans warming, sea levels rising as land-based ice sheets are melting. We're seeing the atmosphere holding more water vapor as it warms. And as we'll learn, especially for people living in the tropics, that's posing an existential threat to their ability to do agriculture outdoors, construction work, for example, serious equity and justice issues, given that a lot of those communities in the tropics haven't been responsible for a lot of our historical greenhouse gas emissions. Okay, how do we know that we are having such a big impact? Let's step back and look on a timescale of almost 1 million years at the concentrations of greenhouse gases, especially carbon dioxide in the atmosphere. You can see here over an 800,000 year timescale, carbon dioxide fluctuated from roughly 180 parts per million to 280 parts per million. Now look, as we get to the far right axis here, how quickly carbon dioxide concentrations have shot up to these unprecedented levels over the last 2-3 million years. We've had about a 40% increase now in carbon dioxide concentrations since the Industrial Revolution, 250 years ago. And we can look at the chemical composition of that carbon and see that it is from the burning of fossil fuels. It's from our activities. But how do we know that there's actually a physical relationship, some causation between those increasing greenhouse gases due to our activities and the warming of the planet? How do we know it's not just a random correlation? Well, one thing is just the very basic physics that have been understood now for over 100, 200 years. Greenhouse gases should warm the planet because they're especially effective at the temperatures that we find, not so much of the incoming sunlight, but the heat and radiation that's bouncing back from the Earth's surface to space. As we add greenhouse gases to the atmosphere, they don't have much effect on incoming sunlight, but when the Earth tries to re-radiate heat out to space at what we call a longer wavelength, those greenhouse gases are very effective at disrupting that long wave, sending it back to the surface, causing even more warming. Okay, so now pivoting to talk a little bit about what this means for society. Most fundamentally, climate change, we may hear about 1 to 2 degrees Fahrenheit of warming. We might hear about 6 inches, a foot of sea level rise. It might not sound like much. You might tend to think, is this something that really matters given how much temperatures vary from one day to the next? This graphic is an effort to show why a little bit of warming matters a lot. And bottom line, it shifts the statistics so we get far more of certain types of extreme events. We get unprecedented heat waves, and we get the kind of heat waves that happened in the past far more often than we used to. And you can see that in this graph as we look at that area depicted as hot. There's an initial bell curve that's shifted a little to the left. That's the climate of the past. If we just warm by a couple degrees, we see this distribution shifting a little bit to the right. Doesn't affect the number of days in the middle, those sort of average days of 50 degrees or 60 Fahrenheit very often. The number of occurrences, I should say, is on this y-axis here, and the temperatures are on the x-axis. But as we get out to those really hot days, when it's 95 degrees Fahrenheit, say, or 100 Fahrenheit, we can see how, as we've shifted that temperature distribution, we're now getting far more of those really hot days. And we'll see some examples from New York City later just to show the huge increase in the frequency of heat waves with just a little bit of global warming. It's a very similar story with sea level rise. We've had just a foot of sea level rise in New York City over the last century, which doesn't sound like much at all. But as we look out to the future, sea level rise rates are expected to increase a lot as that ice that sits on land in Greenland and Antarctica starts to melt more rapidly and physically move towards the ocean where it displaces water, because there's simply more mass. And as the atmosphere warms and the ocean warms, a warming ocean will literally stand taller. That's another reason that there's so much additional sea level rise projected. But even if we end up at the lower end of these sea level rise projections, just 1 or 2 feet this century, which really is the best case scenario of all, this slide is going to show you that the best case scenario of low sea level rise means far more coastal flooding. So it's a bit of a complicated graph, but I think it's important to delve in and understand it a little more. Let's focus on the parts on the left. This is showing you what's called nuisance flooding. These are these events where the weather's clear, there's no major storms around, but people who live right along the coast are not able to use their normal roads. Maybe they're getting flooding in their basements. Maybe they can't open their businesses because there's water on the ground floor. So you can see on that one axis, the last 60 years, starting in 1950 up to about 2015 or so. And then on the axis next to it, we can see coastal stations all along the US coastline. So the critical axis is the vertical one that runs from 0 to 90, which is also depicted with these colors, the red, for example. That's showing you for all of these different spots around the coastline, as we've gotten into the last 5, 10 years or so, these nuisance flood events are happening far more often than they used to, like 5 or 10 times as often. These events that used to maybe happen back in the 1950s, a few days per year, 5 days per year, have already become events that happen once a week over many parts of the US coastline. So we have to ask, who's living in these vulnerable areas and what opportunities do they have when they're experiencing more frequent coastal flooding? Because this is already a huge issue, and with further sea level rise, it's going to become even more of a problem. And then the graph on the right, instead of talking about these relatively minor, if you will, nuisance flooding events, the graph on the right is the catastrophic flooding. Think about the 1 in 100 year events where huge amounts of water pile up during a storm on our coastline. Hurricane Sandy would be an example for New York City of this roughly 1 in 100 year event. Now, what the graph is showing you is if we have that fortunate sea level rise situation, just 1 to 2 feet, the best we can hope for. And even if storms don't change at all, if we just get the hurricanes of the past, how much more often will cities along the US coastline experience that high water level that used to happen once every 100 years? An event that happens once every 100 years is roughly what we're able to get flood insurance for, where zoning will allow you to build. So anywhere on this graph on the right where you're seeing red depicted, those are places where that high water level that used to happen once every 100 years is going to happen every year or two. That's, horrific for a lot of these places, but just about anywhere you look, once every 30 years is shown in green, you're going to have that high water level that people are used to thinking of as something that only happens once every 100 years, that maybe you don't have to worry a lot about. So just a little bit of sea level rise has this radical transformation on the frequency of coastal flooding in our communities. This has huge implications for the ability to develop infrastructure in the future, to take care of vulnerable communities. If we see these increases in coastal flooding, we have to ask what's going to happen to the tax base of a lot of these places. We have to ask, are some people going to start to move away? If they do, who gets to move away? Who has access to the information first? Who gets left behind? These are the types of big issues with huge racial justice implications that we need to be thinking about. I'm going to move more quickly, but just to note that we also expect major changes in what we call the hydrological cycle. These are issues related to rain that's falling. Is it going to change in nature? And by the same token, what's going to happen to drought. So this is showing you historical data, again, for the last 50 years from the National Climate Assessment, as Pam mentioned. You see for the Northeast, that 55 there, that's telling you that there's been a 55% increase in the amount of rainfall that falls on, say, that worst day per year. So when we think about our communities flooding during these heavy rain events, for example, in summer, our infrastructure already can't handle these powerful rain events. They're causing our storm sewers to overflow, they're polluting our waterways, and they're affecting vulnerable communities hard in terms of water quality as well. Not so much an issue for New York right now necessarily, but as we think about the US and globally, we're also seeing and expecting, even as we're having more intense rain events, paradoxically, more drying out and a huge increase in fire risk. And that's mostly simply because as we raise those temperatures a little bit higher, the atmosphere can hold more moisture. And when there is moisture in the atmosphere, it's going to tend to fall out, as we saw on that last slide, as heavy rain events. But the issue is there isn't always a lot of moisture in the atmosphere. If you increase those temperatures, the atmosphere is going to try to suck more moisture out of the land, out of the vegetation. So you increase temperatures, you effectively get much more loss of moisture from the surface. And that's going to give us more of these devastating droughts and fire events, which will have huge global implications too, far beyond New York. Okay, so now pivoting a little bit to talk about some of the critical climate impacts for society. We don't have a chance to run through all of these, but just to highlight a couple examples. So first of all, what we're seeing here on the vertical axis is amounts of global warming. And we've already, this is in degrees Celsius, so multiply by about 2 to get to Fahrenheit. So we've already had 1 degree Celsius of global warming, 1.8 Fahrenheit. And that's depicted by that gray bar running horizontally. So for these different systems, like our coral reefs at the far left, which of course are the foundation for the ocean ecosystems, critical source of ecotourism revenue for a lot of developing countries. The fact that you're seeing red, even purple colors at just 1 degree Celsius of warming is telling you that these systems are already super vulnerable, may even reach a point where they cannot adapt to the levels of warming that they've already experienced. So looking across the board, even crop yields, just with the warming to date, there's a real risk that we're approaching thresholds whereby yields might fall dramatically. So it doesn't need to be 5 degrees of global warming for us to see catastrophic effects. They're already almost here, especially for our vulnerable communities. That's why we need to reduce our emissions immediately. And I'll just give a couple examples that hone in on this heat-related morbidity and mortality. And we'll talk more about that in the New York City case too. So this is work we've done that looks at the combinations of high temperature and high humidity at the same time. Because as we all know, temperature alone isn't what gets you. What's so oppressive on the worst summer days is when there's also a lot of moisture in the air. This graph is showing you if we don't reduce our greenhouse gas emissions, if we stay on the trajectory we're on of burning a lot of fossil fuels, a couple generations from now, by the 2080s, across the world, how often are different cities going to experience that worst day per year that we're used to of that combination of heat and humidity? So for New York City, just sort of visualize in your mind that most oppressive, most sticky day that you experience like once per year. It's that day when you don't want the elderly to be outside, you don't want kids or anybody really working too hard. And then the colors here are going to show you in the future how often we're going to experience that current worst day per year. So you can see for New York, huge changes. That blue is telling you something on the order of 2 months, not 2 days. 2 months per year, 60 days or so, are going to be worse than that worst day per year that we're used to now. But now look at some parts of the tropics. Look at portions of India, for example, Southeast Asia, Western Africa, where we're seeing really rapid population growth. Some of these areas could cross over to a level where on the order of 1 out of every 3 days or 1 out of every 2 days is worse than the current worst day per year. So, we hear a lot about the risks of sea level rise for coastal communities, as we should, but there are other risks too out there. And across the board, it's these parts of the tropics that historically have been responsible for many greenhouse gas emissions, where a lot of people are working outdoors, having to grow crops. Basic sustenance agriculture is going to be hugely threatened with major equity implications unless we dramatically today reduce our greenhouse gas emissions. And even then, we can't eliminate these risks entirely, but hopefully we can hold them down to a level that we're able to adapt to. Okay, another thing to highlight is that it's not just your climate risks where you live that matter, right? This is an interconnected system. We need to worry about the effects of climate change in other places as well. So the example shown here is the NASA Kennedy Space Center along the east coast of Florida. Those are launch pads that you can see in the middle panel, those circles. And then on the right, you can see with the climate of today, how vulnerable those launch pads are to just normal high water levels, even when there's not a hurricane. This is one of the only places in the US where we're able to launch commercial satellites that can tell us how much sea levels are rising, how much the planet is warming. And if these areas get knocked out, we don't really have any backup systems. So you have implications for geopolitics, for the economy. This is one example of how climate change and climate impacts in one region can affect broader regions in the world. Another really important example of this, more important, is related to food security. If we look at vulnerable communities where there's not enough food, maybe that rely on imports of rice or other staple crops, we have to ask if climate change is going to impact other areas like the breadbasket regions of the central US, the Ukraine, East Asia. If climate change causes more droughts in those regions, that's obviously going to mean some suffering for people in the middle of the US, but it could mean even more suffering for people in other parts of the world that rely on those crops for food security. So we're all interconnected. We need to think about how climate change is going to impact all of us because we're not in a silo. And if we don't look out for other areas, it's absolutely going to affect all of us. Just like if we don't immunize the entire world for COVID, if we just look out selfishly for ourselves, whether that means certain communities in the US or the US relative to other countries, say in Africa, we give that virus a chance to mutate, cascading impacts back on all of us. That's a metaphor that I think is pretty applicable when we think about climate change too. We have to look out for everybody here, especially those who haven't been responsible for historical emissions and are particularly vulnerable. Okay, so now we're sort of pivoting to these emerging topics and some of the policy solutions at the global scale before we circle back and really hone in on New York City. So something that we all need to be thinking about these days is this notion of compound extreme events. In the past, we've thought too much about just the individual heat wave or the individual storm like Sandy. Now we need to be thinking about what if we get sequences of hurricanes that impact the same place? What if we get a year where one part of the United States maybe gets hit by a powerful hurricane or two, and at the same time we get record fire conditions in the Western US? So it's different parts of the country affected by different types of storms, but do we have the capacity that we need to deal with multiple stressors? And have we thought about how that first event might make us more vulnerable to the second? So do we have enough emergency responders? Do we have enough insurance to protect against these sequences of extremes? Circling back to an example for major cities, what if a storm like a hurricane or a nor'easter, one of our cold season winter storms, knocks the power out. What's that going to mean if we get a heat wave after that hurricane or extreme cold air after that nor'easter? Will we be particularly vulnerable if the power's gotten knocked out, for example, and our elderly, those with pre-existing health conditions, are particularly vulnerable when that second event hits. This is a major issue I think we need to be thinking about when we're focusing on environmental justice, racial justice issues that hasn't been focused on enough in the past. Okay, another thing that's very relevant, there's a lot of work right now on what we call extreme event attribution. This is the idea that we can do more than just predict how many heat waves we're going to have in the future or how much sea level is going to rise. We now have the capacity to use our climate models to go back in time and to run different sets of experiments. Some where we kept greenhouse gas concentrations constant where they were, say, 100 years ago, 35% or so lower than today. And then we can run those same climate models over the past also, but increasing with the greenhouse gases that we actually experienced. So that from 1900 to 2020, we run them up to the greenhouse gas concentrations of today. And by comparing those two different climate model simulations, one where we kept the climate of the past and the greenhouse gas concentrations of the past, and one where we did what we actually did to the atmosphere, we can look at those two model simulations and see how they differ in the number of heat waves that they produce, see how they differ in the number of heavy rain events that they produce, the amount of coastal flooding. And we can see, for example, that the emissions to date by certain industries, like the fossil fuel industry, for example, have contributed in a real way to more of these types of extreme events. So that's opening the door to issues of responsibility, loss and damage. And as some countries, industries that haven't been responsible for many emissions historically are turning towards this science and essentially looking for compensation. Small island nations, for example, that aren't going to be able to adapt to these rapid amounts of sea level rise are beginning to say someone else should pay for that responsibility. This is emerging science. We certainly can't say exactly how much additional heat waves we've had, but the science is clear that certain countries, certain sectors have contributed disproportionately to these problems. And as we think about equity and justice issues going forward, certain nations, sub-Saharan Africa, small island nations, are turning to these fossil fuel majors and some of these countries looking for compensation for these damages. That's going to be a growing trend as well. And there are implications, within communities in the United States too, as we start to say, how have certain cities been affected by those historical emissions, but maybe also potentially affected by failure to adapt. If certain companies or cities have known that climate change was happening for some time, if they've done assessments, but they haven't protected their communities, if there's continued to be development, for example, that's not as far along the lines, but potentially there could be lawsuits as well around failure to protect, failure to help with adaptation. Okay, so deeper into the solution space, I hopefully made the point already that we cannot afford to have 3 degrees Celsius, that's about 5.5 degrees Fahrenheit or more of warming. We need to get, we've already had that 1 degree Celsius, almost 2 degrees Fahrenheit. We don't want to have more than another 0.5 degree Celsius, more than another degree Fahrenheit. And you can see here how much we would have to reduce emissions. Emissions are on the y-axis, this is global, over time to get on these better trajectories. Right now, we're on that red trajectory, roughly speaking, increasing greenhouse gas emissions. If we want to be able to not blow through a 2 degrees Celsius warming target, we need to get on that purple trajectory. So you can see, right now we're in 2021, you can see the amount of emissions reduction we'd have to do just in the next 9 years or so. And then it continues all the way out to 2050. But really, we may need to get on that gray trajectory. That limits us to just 1.5 degrees of warming, which is what we saw earlier as we need to do to avoid getting into that purple zone, right, where you can't adapt that we saw earlier with the warm water corals, the crop yields, the heat and humidity. So it requires really dramatic greenhouse gas emissions. But as we'll see, it can be done, and it can be done in a way that helps our vulnerable communities most and gives opportunities in addition to just reducing harm. Okay, so these categories of solution I think are going to be familiar to everyone. We really want to hone in on accelerating our efforts to reduce greenhouse gas emissions, what we call greenhouse gas mitigation. We need to do much more of that. And we also have to mainstream adaptation. We can't just be doing this in a piecemeal way. It's going to take a huge investment to protect ourselves from those higher seas, from those heat waves, but we can do it in ways that don't just protect us from climate change, but also give us more green space, a more equitable future with more opportunities. It's not straightforward. We can't just breezily assume that this can all be done, but there are, if we're inclusive, if we engage with communities, get everyone at the table talking about the changes they want, there absolutely are opportunities for innovation, doing things in a new way that protects the climate and promotes other goals such as racial justice. Okay, one more of these hot topics that's very related to the notion of adaptation. People are talking a lot now about managed retreat, this idea that there are some areas where climate risks are just changing so fast that it's going to be too costly for people to continue to live in some of these places. There's going to be more and more of these repeat harms where homes are flooded, for example. But it's not just an economic issue. As sea levels rise, as we get more of these extreme events of various types I've talked about, at what point do we start to see events where people don't have time to evacuate, where we just see so much of an increase in loss of life that that's another reason people have to think about moving away. But these are complex issues. You don't want climate scientists, for example, thinking that we know everything, thinking that we can decide for communities who should leave, who shouldn't. These are decisions that have to be made partly by experts, in the sense of, sort of scientific experts like myself, but also by community experts, because every community is different. And we do have these histories of redlining, for example, where some communities have not had access to lending, for example, that have helped create these situations where some communities are so much more vulnerable today. So as we think about ways to protect people, if we don't think about racial justice issues at the same time, we're going to see those who have access to information first getting out, and potentially even profiting through gentrification from some of these issues. Which communities are going to be left holding the bag as we start to see loss of critical services in some places. There's public transportation. So this has to be done right, or else as we think about some communities where people are going to be moving away and moving to, we run the risk of the powerful and the most informed profiting further at the expense of those who are most vulnerable. So it's this tricky situation where we have to acknowledge that we're going to need to see some of this managed retreat. It's already starting to happen, but if it's not done right, there's a chance that it could make things even worse in some ways, paradoxically. So there's another area that needs much more research. Okay, let's pivot now. Want to make sure we have some time to really hone in on New York specific examples. I'll talk about New York City and New York State efforts somewhat quickly because we need to allow time for questions. So I'm a member, lucky to be a member of this New York City panel on climate change. This is started back in 2008 by then Mayor Michael Bloomberg. We've had a few iterations now. And over time, there's been an increasing focus, not just on the city's infrastructure, but more and more on communities and issues, for example, of environmental, racial justice, and equity. Issues of the environment have become more and more prominent as New York City has expanded its resilience efforts. But there's a strong climate science foundation to this work, which I'll talk a little bit about, as there's expertise in other sectors that you can see here, such as health, social sciences. Okay, so there's these resiliency guidelines I was going to talk about. Very exciting things happening here as we see this mainstreaming. Maybe others will have more details than I, but as I understand it, rapidly changing area here where there's major guidance coming in for different city agencies. It's going to become much more easy and a bigger requirement to take these resiliency steps, to use some of this science to help address these issues. maybe people can see my slides later. I don't want to run through each of these, but I know some folks are going to be interested in going the science route in one of various ways in their careers. Others are going to be really interested in these policy issues. As we think about climate change, it impacts everybody. We need every single field. We need lawyers to be thinking about climate change. We need bankers to be thinking about climate change. We need community groups to be thinking about it. And you get a little sense here on this slide for how we need to engage all aspects of society around these issues. Climate is going to touch everything. And from any lens, you can think about climate and racial justice issues to make improvements. And the key players are on the government side, but they're also on the citizen group side, for example. Critical to making sure these local issues are considered, that local expertise is engaged, and that we see these equitable and just solutions, for example. Okay, very quickly, we saw a little bit of global projections. Now let's talk a little bit about New York City. Remember I said a little bit of average warming can mean a huge change in the frequency of extreme events. So let's just hone in for New York City and look at what might happen to the number of days above 90 degrees per year. So you can see in that baseline climate of today, roughly 18 times per year we get 90 degrees Fahrenheit. But you can see how with warming, there's a range. It depends how much greenhouse gases we emit. But we could see, as you see here, a tripling, for example, in the number of days over 90 to somewhere between 44, 76 days per year. That's one possible scenario, very plausible. So a little bit of warming, big change in these extreme events that we know we're so vulnerable to, right? These are the days when people with pre-existing health conditions, cardiovascular, respiratory, suffer so much more, and we can't have the power going out on those days when temperatures are really high, for example. And then, New York City's coastal flood risk. I showed that map earlier of how cities along the US coastline are going to experience much more frequent coastal flooding. For New York City, we can talk about that current 1 in 100 year flood. Let's look at the 2080s down towards the bottom. The chance of that 1 in 100 year flood in the future. If we look at this, what we call that middle range again, that most likely scenario, the risk goes from essentially 1% per year to 2 to 5%. So that's like a doubling to a 5-fold increase, roughly speaking, in how often we'll have those events. It becomes something that used to happen once every 100 years. Now it's happening every 20 to 50 years. Okay, a little bit of these sort of more local impacts that we can hone in on. Let's just do the temperature example in the interest of time. So it's very obvious, it's very direct. Higher temperatures cause people with pre-existing health conditions to suffer more, causes them to die at higher rates. And there are all sorts of interactions with things like air quality, for example. I think in the interest of time, I'll skip the precipitation and sea level rise stories, but it's very similar, and our vulnerable communities are most affected. So this is showing you from the health perspective what high temperatures do. The x-axis is temperatures per day. So as you get out to 30 degrees Celsius, that's 86 Fahrenheit on the far right. And then the red curve is showing you the risk of dying from any cause. It's a relative risk. So anytime you're above 1, as you move up that axis, more people are dying than you'd expect to die due to chance alone. So that's telling you that when there are heat waves, you're having more people dying of heart attacks, more people dying of asthma, for example. Doesn't always show up on the death records. It usually doesn't show up as a heat death, but climate change and temperatures are entirely responsible for that. And as we go to the future, we expect those number of deaths for New York City to increase unless we do so much in terms of adaptation. And there is room for some optimism here. By decade, we can see historically what those curves look like. And back in 1900, shown in that, I don't know what to call that color, maybe it's magenta. It used to be back then, before people had air conditioning, before we had warnings about heat waves, once temperatures got to 30 Celsius, 86 Fahrenheit, the death rates shot up extremely steeply. Now today, as shown in that red curve at the bottom, the story's gotten a lot better. Adaptation can help. But with climate change, if we warm too much, is that going to win out, making the risk much greater? That's why we need to keep working on adaptation as these risks go up. Across New York State, there are hugely ambitious efforts, some of the leading in the country, to reduce our greenhouse gas emissions. Critically, there's also efforts by NYSERDA and other entities that are leading this effort to focus more on environmental justice and those disadvantaged communities, to think about just transition as we shift our energy sources dramatically, making sure that there are economic opportunities for everyone. So that's going to include things like increases in offshore wind. As you're thinking, students, about future employment opportunities, ways that you can do good, hoping to make the point that there's so many ways to engage. There are going to be huge growth industries, for example, in renewable energies, that wind, distributed solar, energy storage, the advances we're seeing in battery technologies bringing costs down. Things we can do to increase our energy efficiency, smart appliances, for example, making our buildings more weatherproof so they're not leaking out energy, for example. These are all areas of huge innovation. Electrification of boilers, other systems, so that they're reducing greenhouse gas emissions. These are all growth areas with huge policy dimensions as well. Transportation emissions, as we're shifting towards electric vehicles. How can everybody, including people who are thinking about urban design, flow of traffic, changes in how the grid is drawing electricity, times that these vehicles may be able to be used as sources of energy through their batteries, all areas for huge amounts of innovation that can be engines of growth for the city, for the state. Huge amounts of jobs projected in this space. So this is something that we should embrace, these transitions, not something to be afraid of. And they'll improve air quality along the way as well, in addition to improving the climate. Okay, so in my remaining time here, I know we won't have time for questions. Circle back, think a little more deeply, or close the loop on some of these connections I've tried to bring up between climate and environmental justice. So we said that some communities are exposed to more climate hazards, some have more vulnerability to a given climate hazard, some have less adaptive capacity. Let's hone in on those issues. So a recent report by Redfin looked at these histories of racial injustice and redlining, and found that communities that across the United States that were designated as not deserving or worthy of investing in mortgages, on average have temperatures as much as 5 degrees warmer than those same communities where there was this investment encouraged at highest levels. So that's for reasons such as fewer trees being planted, just to name a couple. So these direct ongoing effects, and these same studies have suggested that as much as 58% of the people living in those communities that were designated for redlining are non-white. Whereas if we look at the communities that were able to receive that funding historically, they were only 40% non-white. So there's an obvious glaring racial dimension, racism, behind these differences in exposure to hazards. In terms of the vulnerabilities, here let's think about all the different ways that we see this extreme vulnerability. As I said earlier, these legacies of racism and lack of opportunities stress people, which is an additional cause of death when we couple it with higher temperatures. Who has access to air conditioning, healthcare, who can afford the air conditioning when you get that heat wave? Who's able to take time off of work when we have an extreme weather event, when we have COVID for that matter? Who has to take public transportation? These are the kind of things that amplify vulnerabilities. Who lives in a neighborhood where there's only 1 or 2 places that you can get groceries, and if those go down, you don't have any other options. These are all the kind of magnifiers of vulnerability. And then in terms of adaptive capacity, who's getting support from institutions, who's not getting that kind of attention, who has support networks, who has savings. As we're thinking about the implications for mitigation and adaptation strategies, if we're not thinking about these issues, we can't do it right. And just to sort of give an example of how this relates to COVID here, so we think about just the past year, we've had heat waves, we've had hurricanes, and the environmental justice implications are very clear. if you can't go to the beach during a pandemic, if you can't go to that cooling center, how do you manage during a heat wave? If you need to evacuate during a time of COVID and you have to get onto a packed bus, who are the people who are going to be packed in together and experiencing this double risk of greater COVID exposure, just as you're having that heat wave and hurricane risk? So these risks are all conjoined, and you're not going to be able to do adaptation well or mitigation unless we think about these kinds of issues. So last slide here. It seems a little breezy, but I truly believe this. I've talked about climate tipping points and how the great peril that we face if we don't reduce our emissions dramatically. We could lose control of that narrative. But it's also true that it's not too late for us to be a tipping point for good. If young people speak up, as you are, saying, we're not going to put up with the ways of the past. We are not going to work in places that don't think about reducing their greenhouse gas emissions, that haven't thought about how vulnerable they are to climate change. We're not going to eventually invest our money in companies that aren't trying to do the right thing. That can have a really powerful impact. And you push up that hill, it seems like there's no progress, but we're actually getting to that point in some ways where things could tip very rapidly. The price of renewables is now lower than the price of fossil fuels. Battery prices are almost as low as traditional fossil fuels now. Once we cross some of those thresholds, some of these old industries, some of those old ways of doing things and racially unjust ways start to be exposed for what they are, and you can see dramatic changes. Now, we're not guaranteed any of those changes. Certainly, we're not guaranteed it's going to happen fast enough. But this is a plausible narrative to me in a way that, it wasn't as much, 10 years or so ago. But it's not going to be climate scientists like me that are front and center of that. It's going to be young people speaking with a moral voice who make that happen. So we need all voices at the table across all these dimensions of climate change, and we need to be looking at bottom-up approaches that engage diverse expertise if we're going to deal with this problem. So with that, I'll close. Thank you very much.
Thank you very much, Dr. Horton. We now have, looks like about 7 or 8 minutes for Q&A. And I already have several questions that have come in from the audience. I'll read you a question and ask you to respond. And I think based on what you just ended, I'll start with, how can the experience from fighting the pandemic in New York City inform more effective local climate change and adaptation strategies?
Yeah, that's a great question. So many dimensions to it. It's hard to know where to begin. I think a few that are really interesting and obvious are just that there was so much overlap in the communities that suffered the most from COVID with those that are most exposed to climate. But maybe something like a heat wave is a hidden risk that a lot of people can't visualize. We can see, though, the direct effects that COVID had. So hopefully that can help people see what's maybe not immediately so obvious. It's the same when we think about the supply chain effects that COVID had, expanding vulnerability in ways that are hard to predict. It's the same with climate change. So we have to be aware of those, some of those indirect linkages. Basically, bottom line, protect the most vulnerable and everyone will be protected.
Thank you. And here's another question. We're expecting from the feds a major infrastructure bill soon. What elements are critical to address and mitigate climate change?
Yeah, so some indications that the Biden administration is going to put some of these environmental and racial justice issues front and center in all that they do. As we think about this question in the more sort of traditional lens, one thing that would be great to see is elimination of subsidies for fossil fuels. I said that renewables are already there if they're given a chance. So getting rid of some of those subsidies would be huge. You're looking for investments in things like battery technology, new types of electric grids, new types of transmission lines would be some components to it. Transportation, investing in bus fleets, for example, all federal vehicles, shifting towards electric or even hydrogen powered would be really important elements. Doing it in a way that all of society is benefiting from some of these jobs is critical to get that kind of traction that you need.
This is a question about mitigation versus adaptation. So if the changes are already happening, should we still focus on mitigation or emissions, or should we now focus more on climate adaptation?
So yeah, this is a great question. For a long period of time, folks were saying, let's not do adaptation because it somehow takes away from the efforts at mitigation. But I think we've reached a point now where it's more important than ever that we do both at the same time. Because really, the truth of the matter is, if we don't reduce emissions dramatically, changes are going to happen that it's impossible to adapt to. So that's why we continue to have to reduce emissions dramatically. If anything, the climate risks are growing, so mitigation is more important than ever. I would reframe the question as, how can we do mitigation and adaptation together? What are the strategies that accomplish both? And let's also have them address equity and racial justice issues at the same time. Triple win, triple whammy, and we build more traction that way too. One example would be the sort of a lot of green investments, more trees, more vegetation, can capture floodwaters, can provide shade, and also reduce the need for air conditioning and greenhouse gas emissions.
I think this follows from your perspective as a scientist. What do you think is the climate change impact that is not receiving enough attention from policymakers and the public now?
Yeah, I would, circle back to that example I gave of the humid heat waves. We think there are some parts of the world, parts of South Asia, that are really close to some thresholds where even somebody in perfect health, in the shade, relaxing with an endless supply of water, physically cannot stay cool enough. They'll overheat. So that would be one issue. Certainly food security issues also have not gotten enough attention. But there's all sorts of potential tipping points out there that we need to worry about as well. If we lose a lot of Arctic sea ice, is it going to change our weather patterns across the US and globally that lead to more of these simultaneous droughts that could impact food security, for example? That's another one.
And I think the last question, because we're almost out of time, is, in your opinion, how effective has science been in communicating to the community and business establishments? What more should we do as scientists?
Yeah, I think that scientists have made a lot of improvement in recent years. I think we've learned that we need to use different examples that resonate in different contexts. But scientists can certainly do a lot more. I think there has been progress with the private sector, especially. There's efforts, evidence that there's real uptake now. If the private sector starts to disclose these risks and talk about these emissions, if investors demand it, change can happen very quickly. But are they going to do it in the right way, in a way that's transparent and just, is a critical issue? There's no way, though, that scientists can do enough. Even if we were the perfect communicators, we're up against biases that others have. We're up against disinformation campaigns. And a lot of it is not, ill-intentioned. It's just human nature to not be able to see some of these risks, to be afraid of these narratives if they're framed as negative and risks. So we need all of society to engage. I think scientists can do more, but I don't think scientists are ever going to be the most critical piece here.
Okay, thank you so much, Dr. Horton, for this deeply informative session. I was particularly interested in how you linked extreme events happening on one place on the planet to equity throughout the whole planet, and how every voice is needed. I also want to thank the audience for your thoughtful questions. I now want to invite everyone to the next session, which is a panel discussion about how New York climate leadership will be responding to the Biden administration's climate change agenda. Thank you all, and thank you, Dr. Horton.